Today we are talking about 9-2, exponential and logarithm equations. This is your first time working with logs, maybe outside of specific science classes, otherwise you've never seen this before. Like I said, very important stuff. If you plan to go on to pre-cal and beyond, you will see a lot more of this. Let's just look at both of these equations separately and just kind of focus on their parts and what we do and don't know. Let's start with the exponential function. Lettering aside, you've worked with this on numerous occasions. Here's just a quick example of what that could look like. 5 squared, 5 to the second power equals 25. You've dealt with that for years. So it's that we're talking about here. And how we read it, if we just use the letters, a to the b power equals c. That is one of about 4 or 5 ways to read that statement. You could say to the power of b, you could say to the exponent instead of power. It just depends on what you like to say. But power is just a little shorter, so I prefer to write that one. This one, the proper way to read this is a log base a of c equals b. Log base a of c equals b. Looking back and forth between the forms, you might notice some similarities between them and some clear differences. That's kind of intentional. That's why we use the letters A, B, and C here. So the exponential form, the pattern goes A, B, C. The log form, it goes A, C, B. So similar, yet a little different. It's these patterns that's going to make switching between them very easy to remember how to do. Let's start with those A's. Again, we're going to look back at my little example here. In general, we have always understood that the 5, that's the base number, and then the 2, that's the exponent or the power, whatever you want to say. So that A is the base. This A right here, if you remember from the name, is also the base. So the base in both forms is the exact same number. That doesn't change. What does change is where the B and the C are. They're in different spots, depending on which form you're looking at here. You are going to want to know to be able to switch from one form to the other seamlessly. 1, you're going to be tested and quizzed on it, of course, but 2, that skill will help you solve equations. That's why we show it to you. The good news is you won't have to memorize these forms verbatim unless you'd like to. There is a quick trick that I can show you instead. And this trick is more of an expression, a saying that you remember. I'm going to say it first and then I'll write it out. Base stays base, the other 2 switcheroo. Base stays base. The other 2 switcheroo. You're going to hear me say that more times than you'd like to hear it in these notes, but it'll help. So let's practice switching from one form to the other. We're going to start with the log form, switching over to the exponential form with actual numbers. Before I start, I'm going to write out the form again. You need to know the format of what your answer needs to look like, how things should be placed, the sizing of your numbers, all of that. I will see some interesting things when I grade your tests. Okay. We're switching to exponential form. Rule number 1, exponential forms do not have logs in them. I will see that, unfortunately. No log. Don't write the word log. Start with the base. Log base 2 of 16 equals 4. My base is 2. Base stays base, so my base is still 2. The other 2 switcheroo. So we're going to switch the 16 and the 4. So I'm going to start with 4. 4 is going to be the exponent. And then 16 is what will be on the other side of the equal sign. We'll do that 3 more times. Log base 4 of 1 equals 0. Base stays base. My base is 4. The other 2 switcheroo. So I'm going to start with 0. 0 is my exponent. Equals, the 1 goes on the other side of the equal sign. And I forgot to mention, if there's ever any doubt that you did that correctly, you can always type that into the calculator. You can type the left side in and make sure it works. So I'll show you with 2 to the 4th. 2 to the 4th, I got 16. That's a true statement. It is very easy to fact check this information. So if you're ever not sure, you can check. Third example, log base 12 of 12 equals 1. Base stays base. My base is 12. The other 2 switcheroo. My exponent is 1, and then 12 will go on the other side of the equal sign. Fourth example, log base 1/4 of 4 equals -1. Base stays base. My base is a 4th. And for good measure, I'll use parentheses. We typically use parentheses in the exponent case anyway. The other 2 switcheroo. My exponent is the -1. 4 goes on the other side of the equal sign. Now let's go the other direction, going from exponential to log form. I'm going to spend a moment talking about the format of log form because a lot of students, unfortunately I see this just as much in pre-cal as I do in Algebra 2, do not write it correctly. Let's go back up to the top where it's typed out. When it's typed out, it is exact. It is very accurate. Notice how the A hangs lower than the rest of the text. That's 100% intentional. That's how it should look. So when you write it, and I'm not expecting perfection, but I'm going to show you some clear examples of what I don't want to see in a moment. But write the word log first, and then you're going to move whatever utensil you're using, step down to write the base. In this case, I'm just using A. And then C equals B is going to be level with the log. So you can clearly see that A is written lower than the rest of it. That's your goal there. Now let me show you some clear examples of what I unfortunately see, and these examples will lose you points on problems where the whole point is to switch it. Let me say that. If you have to switch it and then solve and your work is right, fine. But if I'm literally grading you on the format of your answer, I 100% am going to be picky. First option, it's all in line with each other. No, that's wrong. In fact, that means something completely different. We'll get into that later. But this one, this is absolutely egregious. And this is the one I see a lot in pre-cal, and it drives me insane. It looks like someone literally took both of the forms and combined them. Or if anything, put a log in front of an exponential, and there you go. If I see that bottom one, I don't think you know what you're doing, if I'm being honest. That's what's so bad about that form. So either of those, but especially the bottom one, I'm not going to be happy. So this right here is the goal. Okay, I'm done venting about that. First example, 5 squared equals 25. Again, I'm going to see some interesting things on this test. When you're writing a log form, the first thing you should write is the word log, L-O-G. It's kind of what makes it log form. Now we'll do the phrase. Base stays base. My base is 5. This is log form, so we step down. Log base 5. The other two switcheroo. Next we'll write the 25 equals 2. Again, this is log, so start with L-O-G. Base stays base. My base is 4. Step down when you read it. The other two switcheroo. So we start with the 2 equals 1/2. Again, start with the word log. Base stays base. My base again is 4. The other two switcheroo. 1/64 equals -3. Last one. Again, start with the word log, L-O-G. Base stays base. My base is 10. The other two switcheroo. 1 equals 0. There you have it. Questions on switching before we move on to solving? So again, it's important that you pick up on this skill rather quickly and that you're good with it because 1, there will be questions where we just ask you to switch. Pretty straightforward, 1 point right or wrong. And then from there, you have to be able to switch in order to solve equations. And we're going to solve a lot of equations in this unit. Today's notes, we're going to start with just basic equations and work up from there. Before we get to the equations, there is one important vocab word I need to show you. This will not appear in these notes, but in future homework assignments, notes, quiz, tests, this will appear at times. So just be aware of it. The common logarithm, it's the most commonly used one, so hence the name. If you have a log equation without a base number, now I'll just add a note here in parentheses, it is blank. Then the base is 10. I'll do a quick example just to demonstrate what this would look like. Let's say your problem is log of 5. Without being shown anything, a lot of students look at that and either assume the base is 0 or 1. Both of those are incorrect. The base, if it's not there, is 10. So this is the same thing as log base 10 of 5. That's what that means, that's what it represents. So anytime you see a blank space there, understand that there should be a 10 written there, and you're more than welcome to fill it in. All right, let's solve some equations. Evaluate each logarithm below by switching the form and solving. Log base 5 of 125, it looks like it's missing something. It is missing something. Equals x. There is the equation that we're solving. As I said, we're going to be solving a lot of equations, and different types are solved different ways. So this is a habit I'm going to start early on, and I'm hoping it's going to avoid some mistakes that I saw last year. Always identify which form you are using or that you're currently in, so when you go to switch the form, you do it properly. So clearly this is log form, and I know that because it says the word log right there. In order to solve this, I'm going to have to switch the form, which is why we just did 8 examples of switching the form. So I'll switch it to exponential form. Base stays base. My base is 5. The other two switcheroo. 5 to the x power equals 125. From here, this is basically an easier version of what we did yesterday. We need the same base. Let's break down the 125. 125 can be broken down into 5 and 25. And then 25 can be broken down into 5 and 5. So that means 125 is actually just 5 cubed. Bringing this down, I have 5 to the x is equal to, I'll do a complete replacement. This is just 5 cubed. When the bases are equal, so are the exponents. X equals 3. Let's see another one of those. Number 4, very similar problem. Log base 2 of 32 equals x. Now we can solve it. Currently we are in log form, and we're switching it to exponential form. Base stays base. My base is 2. The other two switcheroo. My exponent is x equals 32. Same idea. I have different bases, so let's break down the 32. 32, let's go 8 and 4. 4 breaks down into 2 and 2. 8 breaks down into 2 and 4. And then 4 also breaks down into 2 and 2. And we are left with 5 2's. So that means 32 is actually just 2 to the 5th. Replacing, we have 2 to the x is equal to 2 to the 5th. Bases are equal, so are the exponents. X is actually just 5. Questions on 3 or 4 before we bump it up just a little bit? Number 5. Log base 2 of 1/8 is equal to x. Once again, this is in log form. And I need to switch it to exponential form. Base stays base. My base is 2. The other two switcheroo. 2 to the x is equal to 1/8. First off, we have a fraction. Let's fix that. 2 to the x equals 8 to what power? -1. Remember from yesterday, that's like 1 over 8 to the first, and we give it a negative to bring it back up out of the fraction. Next problem we need to figure out, different bases. We need to replace that 8. So we break down the 8. We actually did this twice yesterday. We have 2 and 4, 2 and 2. So 8 is actually 2 cubed. Replacing, we have 2 to the x equals 2 cubed I'm using parentheses here since there was already an exponent. So I need to take care of that accordingly. 2 to the x equals, what do I do with the exponents? Multiply. 3 times negative 1 is negative 3. We're not adding them. We're not doing 3 to the negative first. It's just 3 times negative 1, negative 3. Bases are equal, so the exponents will also be equal. This means that x is negative 3. Questions over number 5 before I do number 6. Number 6, similar problem, but works out a bit differently. Log base 1/3 of 81 is equal to x. We're already in log form. We need to change it to exponential form. Base stays base. My base is 1/3. The other two switcheroo. 1/3 to the x is equal to 81. Let's fix the fraction first. We'll change it to 3 to the negative first. And then I already had an exponent, so I'm going to use parentheses to separate them first. Equals 81, we can already see is going to be an issue, so let's break that down. 81 is 9 times 9. Breaking down the 9 into 3 and 3. I'm done with the 9s. 81 is actually just 3 to the 4th. We've got the same basis, but we need to take care of multiplying these exponents first. Negative 1 times x is just negative 1x equals 3 to the 4th. Now we can drop the bases and just focus on this equation here. Negative 1x is equal to 4. And we need to divide off that negative 1 on both sides to solve for x. That means x is just negative 4. Questions on number 6 before we do our final two problems. Reminder, if you were not here yesterday, this probably seems a bit odd. It's because we covered a lot of these concepts yesterday. 7 and 8, these are special. They look a bit different when you set them up. Log base 14 of 14 equals x. We're in log form currently. We need to change it to exponential form. Base stays base. My base is 14. The other two switcheroo. 14 to the x equals the other 14. What exponent does the regular 14 have? 1. Any plain number that does not have an assigned exponent, then it's assumed to be 1. So clearly we can see that x is equal to 1. You can also approach it logically. To start with 14 and end with 14, 1 does just make sense. Number 8. Log base 7 of 1 is equal to x. Once again, we're in log form, and we need to change it to exponential form. Base stays base. The base is 7. The other two switcheroo. 7 to the x is equal to 1. Now, unfortunately, there's not a straightforward way to solve this one. You can't break down the 1 or the 7. You can't make a match. So this is kind of a know it or you don't kind of thing. Does anyone know what x equals? 0. I'll give you two explanations as to why this works. First explanation, if I plug 0 in, it works. Feel like that's convincing enough? Because 7 to the 0 power equals 1. So therefore x is 0. More to the point though, this is actually an exponent rule. I could put any number in there and it would work. We can do 3. We can do 12. We could do 528. Any number to the 0 power is equal to 1. It's just an exponent rule. So I'll add that context as well.